Beaver Dam was constructed on the White River in the early 1960s, creating a lake 70 miles long, stretching from Fayetteville to near Eureka Springs, Arkansas. The construction of Beaver Dam began in November 1960 with the preliminary core drilling and grouting work. The drilling was done to take core samples of the earth to determine the structure underneath the site where the dam was to be built. Grouting was done to fill the fissures and cracks in the rock and earth. The construction of the dam was a joint venture by two contractors, T.L. James and J.A. Jones Construction Companies. All the construction was done by contract workers and inspected by Corps of Engineer employees. Concrete placement began in November 1961. They began by cleaning the dirt and loose materials away down to the limestone rock. Steel forms were set and concrete placed in lift joints of 7 feet in height, starting with monolith number 1. The dam was built in 23 sections called monoliths. One can see each monolith by noticing the vertical joints. All the concrete for the dam was mixed at the batch plant that was set up on the south end of the dam, on top of the bluff. The concrete had to be 40 degrees Fahrenheit or less, or the Corps of Engineers would shut down the operation. The reason for this was to prevent thermo-cracking as the concrete set up. The theory behind the low temperature, the cool temperature would retard the setting up of the mix, eliminating the chance of thermo-cracking. Notice the ice house in the upper right-hand corner. It was built near the batch plant to provide flaked ice to be mixed in the concrete batches. In order to reach the required temperature of 40 degrees Fahrenheit or less, chilled water was used in mixing the concrete, as well as cold air blast on the aggregate to cool down the mixture. One can imagine the difficulty the contractors had in mixing the concrete on a typical Arkansas day in July or August. The rock used in the construction of the dam was quarried at the site. The rock was hauled to the rock crusher to supply the limestone, sand, and aggregate for the construction. The limestone was crushed into different sizes of aggregate. Belts carried the crushed material to storage piles or directly to the batch plant to be mixed with the cement. A tunnel also carried aggregate directly to the construction site. Twice per shift, Corps of Engineers inspectors ran gradation tests to check for the correct mix of size and quantity of aggregate. The gantry crane ran back and forth on a trestle. One use of the electric crane was to set sections of forms in place prior to the placement of concrete. Below the gantry crane were 2 railroad tracks. Little trains called dinkies ran on the tracks between the legs of the crane. They carried buckets of concrete from the batch plant to the construction site. The dinky operator connected the hook from the crane to the buckets on the dinky. The crane picked up the 4 cubic yard bucket and swung it over an area where it was needed. It was dumped below and vibrated into the other concrete by workers to make each batch of concrete an integral part of the mass. After all 4 buckets on the dinky were emptied, it returned to the batch plant for another load of concrete. One of the dinkies used on the Beaver project was supposedly used on the construction of Boulder Dam. Notice the dark sections of concrete in this slide. They used curing water to make the concrete harder. They used sprinkler hoses at the top of the dam and let the water trickle down the face of the dam to cure the concrete. This water ran for several days. This is called the keyway. On the south bank of the river, on the bluff side, all the loose materials had to be taken out down to solid rock. Then they put a filling in, like a dentist filling a tooth, but they used concrete for the filling. This was where they anchored the dam to the bluff side of the river. On the north end of the dam, monolith number 1 on the right side was a straight cut and was tied into dirt and riprap. The dirt and riprap were called the wraparound section. They would add dirt and roll it into 10-foot lifts. Then the sides were covered with riprap. They hauled dirt for the embankments from a borrow area at Parker Bottom, which was about 1 mile away. Working 3 shifts around the clock for 5 days a week, work slowly progressed from both ends of the dam. Work shut down each Friday night at midnight and resumed at 8 a.m. on Monday morning. As the pouring of concrete continued, clearing crews began work for the lake. They cleared out the trees for the lake in a band around the lake from approximately 1120 elevation to 950 elevation. You will notice the bare light-colored band in the upper portions of this picture. They cleared the entire 450 miles of shoreline this way, but left some trees to provide cover and shelter for fish. Any buildings that were to be in the lake were either burned or removed. Also, all cemeteries were moved because federal waters cannot cover any type of burial ground. As the dam was built, they left out 2 monoliths to allow the water to go through the dam in the event of a flood. Since there were no floodgates in the dam at the time, this was the only way to release the water and prevent flood damage upstream. Later, the sluice gate was installed, which regulated the flow of the river to prevent flooding. Also notice the concrete wall called the spray wall. During floods, this helps contain the water and prevent erosion to the switch yard. The area directly below the dam is the stilling basin. This is where the water that is released from the 7 floodgates at the top of the dam is slowed down. The water falls with such tremendous speed it would wash out the dirt and rock below. Within the stilling basin are 39 baffle blocks. Each contains 21 cubic yards of concrete. These blocks help to slow the floodwater. Notice the construction of a wall in the upper right-hand corner. This is called the end seal. It is a wall that helps cushion the water as it flows down from the floodgates. Notice the wooden pilings in the lower left center part of the picture. These are sheet pilings driven together into circles and called cells. The water is pumped out, and then they're filled with dirt and sand. These temporary structures are used to divert the flowing water while constructing the dam in some areas. The large steel circular pipe in this picture is called the penstock. It is full of water at all times. The generators pull water through it to generate electric power. The water is pulled off the bottom of the lake by the generators. Also notice the large painted numbers on the steel trestle. These indicate which monolith is to be built. The earthen portion of the dam that connected to monolith number 1 was in several layers. The middle is called the core and made of clay. Then on the downstream side next to the core is a layer 20 feet thick of gravel. The outside layers on either side are random fill, which is a combination of dirt and rock. Then the sides were covered with various sizes of large rock called riprap to prevent erosion of the structure. The main bridges that crossed the river, such as Highway 12, had to be raised before the lake filled. The new bridge had to be much higher and longer than the original bridge. As the lake was filling, the new bridge looked awesome, considering the small ribbon of water that ran under it. Looking at it today, one can realize the need for the tall, long bridge. As the dam neared completion, the lake began to fill. Construction of the powerhouse and switchyard began in April 1963. Commercial generation was begun in May 1965. The powerhouse is operated by remote control from Table Rock. Beaver has 2 generating units, each generating 56,000 kilowatts of power. The power is marketed by the Southwestern Power Administration as provided by the Flood Control Act of December 1944. The power is sold to municipalities, rural electric cooperatives, and public and private utilities in the state of Arkansas, Missouri, Oklahoma, Louisiana, and eastern Texas. The overall Beaver project was completed in June 1966. Throughout the construction, we are proud to say no lives were lost. The purpose for Beaver Dam was to control floods, generate hydroelectric power, and provide water supply. Recreation as we see it today on Beaver Lake was never imagined by our forefathers approving the bill to construct the dam. We've come a long way since the first days in late 1960 when they first began work on the dam. The dam has brought us electricity and drinking water, saved countless lives and property from floods, and brought us all hours of fun and relaxation in the form of water-related recreation. Over 4 million visitors come to Beaver Lake annually to camp, fish, swim, hike, picnic, ski, or just relax and enjoy life. We hope you have a safe and enjoyable visit with us here at Beaver Lake.